Hello, 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 hello. So let's see if the chat's working today. Give me a shout out if you guys can hear me. I'm not 100% sure. I'm getting messages through the system here right now. So give me a minute here while there we go. Okay, now it appears to be working. So for some reason, it's just not counting the visual people. All right, excellent. So everyone's doing well. So we are back to our normal ZClassroom live sessions here for me here on Twitch. So today, the Proko thing we were doing was a collaboration with Proko, and started out originally as being a 3-session stream. So we finished up with that the last stream. But then today I took the model that I completed from Scott Flanders' drawing and I actually 3D printed it out. So today we're going to go through the process I did and some tips and little tricks to get models like the one I did for Proko's collaboration here and print it out to a 3D asset. So I'm going to go through some of that stuff. We're going to talk about hole filling and making the models watertight, and then compiling parts and generating the assets. And in the end of it, we should have a model that you can actually send out and be printed. Now I have my camera set up in crazy mode here today, but first let's go through quick things and then I'll show you guys the printed model. So to start, if you are new to ZBrush or you know someone that would like to try ZBrush, we do have the ZBrush 2020 trial, and you can download this for free for 30 days and you can try out the software and see if it's something you want to do. So we've been doing this thing pretty much since this pandemic started, where one of our developers here will be streaming pretty much every day. So Daisuke went a few days ago, and then I think Saul and Paul are coming on this week. And so if you have any questions about ZBrush or usage of it, definitely tune into one of these chats or these sessions here and you can get some more information on it. Yesterday we also had the ZBrush Masters with Marco Plouffe. So that was an excellent ZBrush Masters. So if you missed that, you can definitely check that out as well. And to do that, if you just navigate over to our ZBrush Live site, we'll take you to this page here. Let me open this up quick. I gotta stop the stream when it pops up because I'll get double streamed here. So here I am streaming here, but if you come up here to the top to the calendar, in here you can find a list of all these streams that will be happening. And so you can see Ashley Adams is coming up next. She'll be following me today at 3 p.m. And then if you go to calendar here, you can get a whole list. And if you come back to May 26th, you'll see the ZBrush Masters Marco Plouffe session here, and you can actually rewatch everything we do for live streaming. So if we ever record anything about it, we can go back and you can rewatch it on Twitch. So here we have the thing here with that, and then you have the playlist for the session down here at the bottom. So if you didn't check out Marco's session from yesterday, definitely check that out because it was some great stuff on how he does all his hard surface stuff for his games and collectibles. So questions, we have some questions already in the chat. So I will not be talking about poly painting in this session. I'm going in more of the 3D printing kind of stuff, but I won't be going into depth in poly painting unless, if you have a question specifically to poly painting, I can probably answer it for you. Definitely this session is gonna be focusing more on the 3D printing today. So we will be covering a lot of that stuff, but it is a ZClassroom live one. It's not the Proko collaboration today. So I have a little bit of freedom to kind of go off on tangents. So if you have a poly painting one, definitely question there, just put it in the chat and we'll try to get it answered. So this was the final Proko model here, and I went back and finished the little guy off too. I didn't give him a whole bunch of crazy details or anything, but just enough where he looked finished with the rest of the model here from the Proko collaboration, and then I just have him resting on the shoulder there. Now with the model, I went through and I keyed it up and I printed it out, and if I can get my mouse here to go where I want it to go, I can show you guys the print. So this is a FDM print. This was done on my old MakerBot Replicator 2. And with the pandemic stuff going on right now, it's kind of hard to find isopropyl alcohol. And so I didn't print it on my Form 2, so I did definitely just print it on my FDM machine. And I'll just do this for a lot of stuff because I get a nice size out of it. So this one's about 8 inches tall to the top of his horn here, to his feet. And so I printed him in a few different parts. So I have this whole front section with his hands is one part, his upper torso is one, his legs here. Oh, sorry, I'm trying to navigate the camera here. His legs here, and then his boots are separated, and then the hose on the back is separate too. So just a few different pieces, and then the little guy here, he just kind of rests like so. He's got some kind of keys built in with to boolean out of the top model there, and you can see it fits right there, and he'll just sit nicely on that. So the detail resolution for an FDM printer is not going to be that great. So this I ran through. Let's see if I can get the focus here to hit on this quick. Come on, focus. Come on. This camera's usually pretty decently good, but it may be having troubles today. It's decent. So the resolution itself, once it is a FDM print, and this is also a replicator too, I'll use Simplify 3D is what I use for all my slicing. So I'll take this is a pure ZBrush model. I export it out, decimate it at about 250K, and then I'll send it to Simplify 3D. And then in there, the only thing I do is just kind of register it on the bed so that most of the print, the part that I want the most detail in, is going this way. So if I printed him like this, he wouldn't have enough, resolution as well if I print him like that. So his details are going to be better if I print him like this than versus like this. And this is just because your X and Y axis on a 3D printer are going to be your lowest resolution compared to the height. So this can be controlled a lot easier and give you different height variations for your Z depth, but then your X and Y is going to be lower. So that's the main thing with any FDM prints to get the resolution on it. But he himself is actually, it's at an 8-inch size for this model. You can see some striations and you will get some lines, so it's not a perfectly smooth surface that you would get from a Form 2, but it takes a lot less longer to print, and it's also extremely cheap. So this was not even a full roll of FDM. This is about a half roll of a 2 kilogram spool, or not even a 2 kilogram. I think it might have been 1 kilogram. So it wasn't even that much material, and then he's really light, so he's not that heavy. And then I just printed him out in parts to fit my 7-inch bed. So I'll do this a lot. Total time for this, the most time consuming part was the main torso here, and that was about 10 hours for the main torso. The gun was about another 8, and then everything else was like 2 hours. The little hoses were like 15 minutes. So it's really not that slow. It's pretty fast, and it's extremely reliable. So my Replicator 2, I don't really break it out all that much. Like I have it in a box to keep the drafts down. And then the main thing I do, if you have any FDM machines, is if you're not using it, just take the filament out of the print head. So just unload the filament. And that's the biggest thing. If you do that for your prints or for your FDM machines, they're gonna last you forever, because the biggest pain is if the filament snaps because it gets too dry or brittle, and then you won't get a good print of it. Yeah, so about 30 hours, I'd say. I did it over this past weekend. So I started it on Friday, and I think I finished it around Saturday. And then for gluing him together for FDM stuff, there's a bunch of different finishes you can do too. So I usually print in white because I can achieve better paint qualities on it if I want. So if I want to print it light or paint it light colors, I don't have to worry about doing a primer coat that's really like a light coat multiple times and then paint color on top of it. So I'll end up doing, most of my prints I use is just white FDM PLA material, so he's all PLA. A few things with this for joining him. You can use stuff like there's a 2-part epoxy that works really well. You can also heat it up and fuse it back together. Hot glue works, super glue works, and then this was Gorilla Glue. So I had some seams in the different kind of areas where I had it, but Gorilla Glue will fill in those keys. So when I make keys here, I'll make them a little bit bigger so there's a little gap, and then you just put a little bit of Gorilla Glue in there and that'll expand and fill that key area. So it works really nice and makes it pretty durable. And then with the printing or other stuff too, with PLA, it will melt. So if I put it in the sun, I'm gonna have craziness. Like he'll turn him into like a Gumby character. But one thing nice about PLA is if you have any strings or anything that's on the print, you can hit it with a heat gun really quick, and now go through and just remove all those little things, and also allow you to shine up some different materials too. So some of the horns here, when it was printing, it was doing this kind of method back and forth, and I had some strings, but if you just hit it with a heat gun really quick, all those strings go away, and then you end up with the nice horns on it. Yep, and we have some comments here. You can use a 3D pen for glue too. Yep, which will just feed filament to it. So it works really well. I use it all the time for this kind of stuff, and definitely large stuff. It makes a bit difference. Like, it's not going to give you the detail compared to a SLA or resin machine, but for anything that's large, it does a really nice job. All right, so let's see here. We got any questions here? So one question about resin stuff. So this one is extremely cheap because you get a spool of material, and you can get like a kilogram, 2 kilogram spool for about 20 bucks. And then Hatchbox has been what I've been using recently, and just get it off Amazon. And then I'll just feed that in the machine. And then the worst thing about it is that if you have like a quarter of a spool left and you print something really big, you may run out halfway through. So that's like the worst thing, is like not knowing, at least on the MakerBot, when I'm gonna run out of filament. But everything else is good. And then, oh yeah, for the question for printing, it was about 30 hours. So it was about, you're looking at 10 hours for this top part here. I'll show you the parts broken down. And then his legs here was another probably 7 hours. And then the boots were 2 hours. And then the front gun was another few hours too. So I have it broken into big chunks. And I basically broke it into the big chunks so that I could piece it together. And if I was doing this for like a projection piece, or say taking it to an SLA machine, I would have it where all these pieces could be broken up and I could paint them individually, because there's a lot of undercuts on this model, like through here. And some of these things would be really hard to paint if the model was all put together. So like getting into the underarm area with a brush is gonna be extremely hard with everything together. But if you have it broken into parts, you can go in and paint those sections a little easier. All right, so let's get into some ZBrushing now. We'll put him over here. And so here we have the model. Let's go back to my little camera view. And I'll show you guys the final pieces we're gonna do today. So let's open this up. So this is the kind of final one here. And this is basically what I sent to the printer. And so I can show you all the little pieces here. So this was the top portion of his body here. So this is all watertight and sent for printing here. And then I can go through these really quick. So we got the boots here. And since this was done with the FDM, there's no hollowing on these pieces for the FDM printer, since the FDM printer will hollow itself. Like, it'll have an infill setting that you can use. And so you don't have to worry about any of that. You can just print it. And as long as you have this stuff all lined up and clean, it'll print on the machine. And then Simplify 3D, I find, does a really nice support structure. So anywhere support touches, I may be going back to big and large camera mode here quite a bit, but I got a medium camera mode too. Look at that. So you will, like, if you look right, I don't know if you guys are going to see this. Let's see if I get my hand to focus here. But you will get support stuff. And so definitely where support hits, you're not going to give as much resolution as you had other places on a mesh. But the trade-off that I find with Simplify 3D is that if you print with that, I can rip the supports off very easily. Like, it's going to give you a lot of supports. You can over flood the supports, because I usually want more supports than less. But with Simplify, I can just take them and they peel right off. And that's the biggest thing I like about that application for 3D printing. Because any other ones that, like, where you have less supports, you may spend a lot of time now cleaning up where those supports were, or taking those supports off. And if you have a lot of supports, definitely on a complex model, if they're stuck on there really well, pulling those supports off, and it just ends up with like so many bloody fingers. And currently right now my hands have no stab wounds on them from dealing with this print. And so that is definitely a big choice there for me. Check here. Yeah, so I'll be going over the making keys with in this session. So I'll go through and show you guys how I set all this up. And then I'll also go through and show you guys some hollowing too. So I did go through and hollow these pieces too. So in case you were printing it on an SLM machine, definitely you can do that as well. So I'll go through that too. Another question here. So no plastic is asking about getting rid of lightbox files displayed as black icons with question marks on them. If it's in lightbox, it should display as a mesh. Are you talking about brushes or just files in lightbox? So all these in lightbox should be displaying. If they're not, I'm going to have you come up here to the help area and submit a ticket to support. And we recently just upgraded our support system too, but that link still should be valid there, and you should be able to submit a ticket there. But you should, everything in Lightbox should show with an icon. Some of the brushes over here, if you load them in, you may get a little question mark where this number is. And if you have that happening, you can just go to the brush palette and then go reset all brushes, and I'll run through them, and then that should go away. So that's the only time I've really ever seen a question mark would be on a brush that you've loaded in and it tries to fill in this number here and it can't find the number, so it gives you a question mark. So that, if that's what you're talking about, then definitely do brush, reset all brushes. But if it's in Lightbox, you should just be able to delete the files and they should go away. There shouldn't be any ghost files in there. I haven't seen that yet, so that's a new one. All right, so back to the printing here. So these are just the parts. So this was the gun, and then you can see the tubes, and then finally the little buddy guy here from the Proko model. So those were the basic parts. So it was 8 parts, and I printed the boots at the same time. So these are were printed like this. Pretty much I printed everything as it was pretty much displayed on the mesh. So he got printed pretty vertical. The gun got printed like this. The legs I actually flipped, so the legs were printed like this. The tube was just laid on its side, so I printed that like that. And then all the other ones were standard. So the body, I printed him, pretty much vertical too, just like that. So I didn't do any weird orientation things or anything like that. Like, I know you're always gonna get prints or supports with 3D prints when you're doing FDM machines. So it's not really, you can't really get around it. I mean, you can get around some, but most of the time, just add the supports. And if you're doing something with like Simplify 3D, it's really easy to remove them so they don't hinder that much stuff. All right, so that's the process there. So we're gonna go through and we're gonna make all these little parts today, and then we're gonna talk about some different things and some different workflows. So this is my build file for the part here, and this was the final one. And so he's pretty big. So he finished out at around 23 million points. So there's a lot of data here. I've gone through and broke everything down into different folders here. So you can see these are all his folders, and I have these broken up basically in chunks. And so when I'm actually modeling stuff, I usually try to model, like if I know I'm going to 3D print it or potentially 3D print it, I'll make sure everything's watertight as I'm using it. And in the long run, this saves a lot of time, because basically if I just go to, say, the helmet here, let me just isolate that part there. Actually, we'll start with the chest and the helmet. We'll do both of them. And so if I come in here and kind of look at this, all my parts that are made out of this, so if I go to my chest here and go through these, all these parts themselves, so each individual subtool that's making up his chest, they're all solid pieces. So if I build solid off the start, I don't have to worry about that towards this 3D printing process. Like, I know that all these pieces are already solid, so even the hoses here, I have them capped at the ends. All these things, there should be no holes in any of these, and that's just how I built the models, right? And so if I build the models like that, I should now just be able to take these models and merge them together, and that's gonna give me another watertight mesh. So if you have watertight parts, they're gonna allow you to merge those together and you'll be able to get a watertight mesh. So these are all the different little parts here, and they're all watertight by themselves. So if I merge these together and then use the boolean system, I should end up with a watertight volume. Now, when I do this, so after I have my pieces kind of set up, I'll go through and definitely merge them all together. And after they're merged together, I'll do a quick check. Now, you can do this check before you do a merge as well, but you need to do it pretty much without folders. So if you've gone through and used the folders in ZBrush and you want to do this process, I'm going to show to quickly check your model, you would have to go through to each folder and just duplicate your file and then do a delete folder option. That's going to be your quickest way, and just delete all your folders. Because after you have all your little parts, here I've got we're doing a cook and show style again today. Now we bake it in the oven. Doug, I have a file for you. So Doug was asking about this. Here, I got some links to share. All right, so first, this is part of the Proko project we did with them. So we did a collaboration. So this model is in, this is the 3D printed version of the Proko collab. I'm gonna totally not spell that right, but we're going with it. And then for Doug, here you go. It's coming, Doug. It's coming. I found it and I uploaded it for you, and you can access it, and anyone else can access it. So I just shared, Doug's been asking me about this 3D printing joint file that I made for 4 or 8 is when it was. And I had it up on the old ZBrush Central, but we've upgraded the new ZBrush Central and it somehow vanished. So I re-uploaded that to my Gumroad so you guys can just grab it for free. You can modify it, use it, do whatever you want with it. So it's basically yours, so have at it. And that will allow you to create a quick toy joint on your models. And so that is in chat, so you guys can grab that and then use it to your heart's content. So hopefully that will help. All right, so what I did with this, back on topic, we're going on a lot of tangents today. It's a Wednesday, it's gonna be tangent day. So I would go through and basically I wanna make sure, like I know all my parts are watertight, and now I wanna just check them quick. So I'll take all my parts that I have here, like every single mesh, and I'll just merge them all together and make one merged file. And then after that is merged, I will have this kind of version of it here. And I'll just go through and do a union on it. So I'll activate the Gizmo 3D, I'll click this little gear icon, and then in here I'll do remesh by union. And it's gonna take my file, and it's just going to take all those pieces, and since they're all watertight, this should work, and it'll just remesh the entire object and give me one single volume. Now after this volume has been generated, what I can do now is I can come through and I can add a cube to my scene here. And you can do this with all your subtools as well. You don't have to merge them together or do this part, but you would have to get rid of your folders. And so basically I'll have my main object and then a cube that I set to subtractive. And this is gonna give you this kind of preview of my model as if it was being sliced. So if I drag this through the mesh, you can see it's gonna give me this slice effect. So what I did here was I just generated a cube. I set that cube to subtractive. I set one of my subtools here, so this whole check one here, which was just the union version of my merged object. And then I made sure the eyeball icon's on that one, eyeball icon's on my cube, and then activated live boolean. And now if I drag this cube through my model, it's gonna give me this slice effect on the mesh. Now what I'm looking for here when I do this is I'm looking for areas of the model that may not be fully solid, okay? So as you can see, as I scroll this up, most of this stuff is looking pretty good. So you can see the legs through here. Let me get a different angle here. Let me see if I can add some color to this slicer. There we go, a lot of blue, so you can see where it's slicing. And this is just a box, so if I turn on my wireframes here, you can see this is what it just looks like. And when I'm using the gizmo, I'm just dragging this through the mesh. So I'm just taking this and dragging it through, and since it's set to subtractive, it's just removing that mesh data. And so that's all I'm doing here with this process. And then I've just colored it blue so you guys can kind of see this a little bit more. So as I drag this through, you can see all this stuff's looking pretty good, right? So these hoses should be solid. So this is what I'm looking for. I want a nice solid area. Now some of the gun in here does have that opening because it had that area where I made the kind of, where it looks plausible in terms of its potential functionality. So this hole right here is okay because I know this is going all the way through, right? That's okay. These are looking correct. That's just the fin blades or the turbines I had in there. But you see, as I get up to the hands here, this is one area where I'm seeing an issue, right? So this area through here, since it's just the hands connected to that handle, this should be a pretty much solid mesh. And I shouldn't be getting this area of openness in between these fingers. So this, to me, I look at this and I go, oh, I've got a hole in there or a volume in there that I need to fill in so it gives me a nice solid mesh. There's no need for me to have that open area space in there. And you can see both of these hands as I scroll through this will have that same kind of thing happening around that handle. So these are holes I'm looking for in my mesh that I need to fill with geometry, so when I merge them together, they get all nice and watertight. This is going to cut down on supports, it's going to cut down on any issues you'd have when printing this. And so I just scrub through the entire mesh and I look for these little areas. So here's another area right here. So you see that hole right there. And this is related to the tendrils or his tentacles going into his helmet. And so this should be a solid volume. Like if I look through here, this should be solid, right? I should not have any holes in that area. So as I'm dragging through this, and if I'm seeing this kind of stuff up here, I know I have something there that is making a hole and it's giving me that internal shape. And so you can see even in the back of the helmet here too, I'm getting a hole as well. And that should be pretty much a solid volume too, because all this should be intersecting all the way through. So if I rotate around, there shouldn't be any really visible holes in those areas, so that should be a solid mesh. And so this is just the check I do with the model. And it's really fast to do it at this stage. So I just modeled it. I didn't care about this happening at all. And then after the model's done, then I can quickly just take this and apply this check and then just see where those issues are. And then at this stage, I'd go back to my model and let's take the chest and the helmet and the tentacles as an example here. And so the first thing that I'm going to clean up here is I noticed I had that area that was kind of behind the tentacles here in his helmet that was opening up. So if I turn off the helmet tool, you'll see that's this cavity right through here. So I'm getting this cavity and I should go in and fill this in because it could be leaking, you know, through the mesh here. The other one with the tentacles has another thing. So I want to go through and just kind of clean these up and solidify these different parts, because if I had a mesh intersecting all the way around, say this ring, or a mesh intersecting all the way around this, it should fill those holes. But just to give it a little more volume, I'm gonna go in and I'm gonna take some geometry and then just deform it to that area. So if I take the chest as an example of this and just come down and just select any of the parts. So I'll just select this one here. And now I just want to insert in a sphere object. And so for any of this hole filling, I'll just take a sphere and just put it in the model. Right, so I'll come through and I'll just insert this and then grab a polysphere. It's going to come in like so. Depending on where it is in space, you may need to first unify this. If you go to deformation and unify, it should bring it back to the center of your model. And then I can scale this down and kind of fill that void through there. So just sticking it right in there like that. And I'll usually bring it in and make it a little bit big. And then at this stage, I'll go to the draw brush and I'll switch to the move brush here. And I usually do a large size here. And I'll just move this into my volume. Now, once again, it helps if you set some color to this too, so you can kind of see where this volume is filling compared to the rest of your object. It's because I don't want it to seep out through the edges unless I want it to. So I want to kind of come through and fill all my voids like this. And so I'm just going through, making sure this sphere is only going in the area I want it to go and not going anywhere else. And you can come through and just quickly fill this in. And this is just using the move brush on that sphere. And this is a big thing too, if you're ever doing anything with Dynamesh or even projecting and you have holes on your model, you can use this to fill anything. And even if you have single-sided surfaces, if you can get it to kind of fill the hole with closed holes, but then it may make a mess, you can end up using this process and you can use it with the with Dynamesh and it'll seal up that hole. Quite nice too. And then I'll take the H-polish brush and I'll just clean it up a little bit. This one has a lot of intersecting parts, so I have pretty much the majority of these cavities already filling out. So that was one of the main things I was trying to do when I was building the mesh. So I don't have to be too specific with this. I just don't want it showing up on the rest of the model too much. So I just want it only be in the areas where it is. And you can spend quite a bit of time, filling this out. And then when I was modeling this too, these little gaps here that I have in the armor, I just did a quick really thin, plain geometry piece, and then I stuck it in that area and I just booleaned it, and that just gave me the gap. So instead of going in and carving by hand, I just stuck a piece of geometry, ran it through the boolean system, and then that gave me this nice kind of hole through here. So I probably want to clean that up too, so I'll take that move brush and just move this piece up so it's in the hole there, something like that. And then I'll switch to, say, clay buildup or smooth. I just want to fill this in a little. So it doesn't have to be, you know, super precise, but just enough to kind of clean up that area there and give this not as much of that kind of hole going all the way through. So if you do anything with booleans, you can always go back in and fill in the holes like the opposite direction. And then, so you can use the booleans in like a just really destructive way to cut holes really quick, which is going to save you a lot of time. And then you can go back in with a piece of geometry and fill those in. So for the gun too, a lot of the stuff I did was just taking single sheets of a cube that was really, really thin and just putting where I want it, and that gave me a cut line. And then after I had that boolean processed, I went back in with a sphere and just bumped and filled in those areas a little bit so it looked like a panel edge. So instead of going through and making the whole thing fall apart if it was 3D printed. And so that is the kind of the quick process for that. And I have a version here. So this was the final one. I ended up doing that. Let's get rid of the junk one here. So this was the fill I did on that mesh there, and then I'd check it on with the rest of the subtools too, but most of the stuff I had was going to intersect with the models themselves, so I wasn't too concerned about it being super precise. I just needed to fill that hole. And then for some of the other areas here, so we mentioned the gloves had that kind of hole in it too, and so you can see these are the gloves, right? And then if I put those on and put them on with the weapon, you'll see this is how they were kind of fitting around the weapon there. So you can see these kind of holes, and this is what was showing up when I was doing that slice in these fingers here. So I need to fill those in. So for each of those gloves, I also came through and I just took a sphere object. This is all it is here. And I just filled that hole, and then I just made sure it wasn't sticking out all over the place. And so that was that hole fill there. And then this one filled over there. So now I have those looking nice and neat on the mesh too. And so that's a main thing that I'll go through on any model, is going in and doing those kind of little hole fills. And if I go to the weapon too, you'll see that with that subtool, I have quite a bit of hole fillers right through here. So if I go to just the main part here, you can see all these little lines here I did for these cuts. If I turn off my hole fills, you can see they would go all through, straight through the model. So it was really easy to just get those lines quickly by taking a piece of geometry and just making the Boolean hole go all the way through. But then when it comes to a 3D printed form, I don't really want that hole, you know, being a true hole, because then the model would potentially fall apart when I went to print it. So adding this kind of hole fills in all over the place. And you can see I do them quite a bit all over different areas on the mesh here. So I have quite a few for this model as well. And then after we have all those holes filled, we can now double check. And this is, I took the head, I knew what kind of pieces I kind of wanted to do a test merge on, and I merged them together. And then I ran them through ZBrush by Union again. So I will do this process live in this few seconds here, but for some of these bigger ones that are in the millions of polygons, it does take a little time to process. So that's why I kind of have it set up as a cooking show today with some of these pieces, because you'd be sitting here waiting while this remesh process, or why the some of these hollowing I'm going to do later processes too. And so some of the processes, depending on how heavy your mesh is, can take some time. So a lot of these I've just gone through and just given you the results. So this is the remeshed by Union one here. And then I'd append in that plain 3D object again. We're not going to do a cylinder today. No cylinder today. And then I'll set the one object as on, set my cube as subtract, and then just drag it through. As you can see, it's filled in pretty much everything. So I got all that stuff through there, but I'm still getting this gap through here. Even though I went in and backfilled, say, that helmet, I still have that little gap there. And so this is another thing that you need to kind of look out for when you're modeling stuff, especially for 3D printing. So if I look at this mesh, you know, all this stuff looks pretty solid. Like the remesh by union looks like it came through and it solidified all this stuff out. However, there's this one hole and it's right here. And so this little tiny hole where these two pieces of geometry don't fully intersect, what this is doing is creating a pocket in my model. And so if I hide part of the model here and then turn on double-sided, you can see here is the pocket. So this area right here is that pocket geometry, and it's all leaking in from that tiny little hole. Yeah, I can turn on polyframes there. So this is the remesh by union geometry. This was all dynameshed, and then some of this had traditional subdivisions, some of it has sculptress geometry, so it's just a wide mixture of all the geometry through there. And then after it's processed with the Boolean system, everything's gonna hold. Your original geometries are all gonna hold. So this is all the original sculptress data, this is the subdivision data, this is that data from that polysphere, and it's only gonna change the geometry where the parts intersect. So where those meshes intersected when I applied the Boolean is where those geometry is going to change. You're going to get triangles around those areas. But if you have those areas pretty dense, like definitely if they're dynameshed models or even sculptress models, you're not going to notice those triangles changing anything. Now you can use the live Boolean with low resolution meshes too, but just remember it's all going to be where those parts intersect, you're going to get triangles. So if you do it with stuff that's too low, it's going to end up causing a lot of these triangles on your mesh, and you're not going to retain as much of your original structures. And so you can see now I have this hole through there. So to fix that hole, basically I went back to my original model and I located that part there. So I went to the helmet. Where are you at, helmet? Actually, it was the tentacles. The helmet and the tentacles together. They were working in tandem. And then I located the tentacle that was causing the issue. So I have these all separated out. And then I just came through and used the move brush and just moved it so it intersected. And that was the fix for that. So you can run through it and just use that live Boolean cube to check where any of that stuff is. You can also hide stuff and turn on double and see if you have any of those pockets. But you want to get rid of all those pockets. And oftentimes those pockets, if they don't go away, like if they're not their own geometry island pocket, they won't go away because there's a hole and it's actually connected from the outer surface, and then it's coming in and creating that shape. So oftentimes when we get anything kind of in support tickets or stuff where people are trying to 3D print stuff, there's often a lot of those holes and they'll cause a lot of issues. So just make sure that when you're dealing with anything with print, that you can check it with the live Boolean system there, and then you can go through and go back and just make sure stuff intersects. As long as it crosses over, you're gonna get a good seal on that, but if you have a hole, you're gonna get that leakage. So David's asking, hey, I'm doing sculpting every day, and how should I approach this and what would make good at ZBrush? So sculpting every day is gonna be your best. 100% that is your best way to get better at sculpting and also ZBrush usage. So the thing that I hit on most for anyone that's trying to learn ZBrush is do it every day and do it at least 15 minutes a day. And then you can set yourself up for a month where you do one sculpt a day, right? So you do, you start on the first of the month and then you go all the way to the end. And even if you sculpt the same thing, like say you have some asset or some part you want to make, like as an example, say you want to make, the Avatar series is on Netflix now, so we've been rewatching all that. And so let's say you want to make the Avatar, right? So you can take that and you sculpt him day one, right? And then say like on Wednesday that week, you do another sculpt of him. And you don't get attached to your models, you just sculpt them and go on. At the end of Friday, if you're sculpting Aang for 5 days, that fifth Aang is guaranteed gonna look better than your first Aang. And so that's the biggest thing there in terms of growth. It's that repetition, 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 and then also just doing it. If you don't do it, you're not gonna get any better at it. And so by doing it, you're gonna increase your skill set, you're gonna increase your knowledge, and you're gonna find little tricks and things that work for you. So you may have done it once, but then when you do it again, you're gonna remember and go, hey, this worked really well, and now you're gonna do that. And then that's gonna make you better. And then it's all just going through and doing that. And so for like suggestions of stuff too, I see you have a question on that. There's a lot of good kind of things. There's, let me see if I can find this kind of thing here. The Inktober type stuff is particularly amazing when that comes around. That's Jake Parker. He started that, and he does like this little thing where there's a month and there's a keyword every month. Another one is, let's see if I can find this. If I have a friend named Andrew, idea, let's see if I can find his thing here. He has this little app, if I can find it, called the Brainstormer. And it looks like it may need Flash. But you can get the app on your iPhone. And basically what it is it feeds you random stuff. So it has a list of things. And you can go through and you just run it, and it's going to give you keywords. So like you can see, as you ran it this one time, it's going to be the bully, a drunk, an alchemist. There's your sculpting. That's what you're sculpting today. And then tomorrow, if you need another one, you hit it again, you're going to get a totally different one. The scoundrel who's orphaned and he's a ranger. There's your second sculpture. So that's a cool thing to use, definitely just for ideas and things to sculpt, and just have fun with it. Don't try to like get bound up. And the one thing I can definitely tell you is, just don't get attached to it, like, because you're going to throw away a lot of models. And it's just getting that progression. Like, don't start your model one and then try to like finish him through the entire week. Like, what I recommend is just doing one a day and then go to the next one. And then when you go back and look, you'll see yourself progress. And then if you find one that you really like, you can definitely go back to it later. But it's just kind of that new fresh eyes and things like that. So let's see what else we got here in terms of questions. Mary, was that geometry sufficient for you? Here, I can show you the geometry for these. So this is just a lot of, for these meshes here for the Proko collaboration, I just modeled however I wanted to model the piece. So these were those Z-remeshed ones that I did. This was just the polysphere that's been Dynameshed. You can see the Dynamesh topology. This one's all Sculptress Pro. So it's a whole collaboration of different polygons through the entire thing. So we got one question. After we unify a model, is it possible to get it back to its original scale before the unify? You can, for sure. And so basically what I do, like this model here, as I'm working on it, so I just imported a sphere. That was the initial thing I did for this mesh, and I just started sculpting. For this entire model, when I was making it, I was not caring or thinking about the size. So I did not put any information or anything in this entire model as I was creating it related to what the scale of this was going to be. I just modeled it. And so after I modeled it, then I decided I wanted to print it. And then at that stage, I was like, hey, let's see, maybe 8 inches tall would be a good thing. So I took the model and then resized it then. So you can definitely go that route where you don't worry about sizing or scaling or anything until the final thing, because one thing nice about 3D geometry is that you can size it up and down. Now, if you have something that you need to work specifically on at a certain size, then you would want to set your scale on it. So if you had a bolt or something or a ring that you wanted to generate art around, you could set it at that specific size and then sculpt around it. So you can do both ways. But for something like this, in terms of my own stuff, and I know I can always resize it. So I'll show you guys how to resize too. Mary's asking, what's the best way to prepare a model for an Unreal Engine? So some of the process in which I did for this will work. So basically, a lot of times the process is that you would generate a high resolution model, especially if you want that kind of stuff in your game or the Unreal Engine asset. And then you generate a low resolution model, you'd export out the high, you'd export out the low, and then you do this process called baking, which takes your high res and takes your low res and calculates information from the normals between the high and the lows, and then it generates a series of maps. And so those maps would be a normal map, you can get cavity maps, specular maps, also AO maps out of that, and then you compile those together and put them on your low resolution model, and then that gives your low resolution or in-game model the appearance that it looks like the high resolution model. So that's your kind of main process for that. So this whole model here would be the high resolution version of it. And at this stage, I could try to merge everything together, make it watertight, and then try to run the Z-remesher on it, which would give me lower res topology. But some of this stuff may be too crazy for that to handle. So like the transition, say on like this wire here from his thing, like I could generate a low resolution decimated model. I could generate a low resolution model that may have the same silhouette, but But in terms of having the correct topology to pick up all the details I want, I'd spend a lot of time probably going in and retopologizing this model. So anything that's kind of cylindrical, I'd want a cylindrical shape around it. And so like things like these cut-ins through the back here, this could just be, you know, removed. So there's a whole theory and process on taking a model and generating a low-res version on it and determining out what angles are needed to catch light, and then what angles are needed for doing projection surfaces. But you can all get it down. If you just want to throw the static model into, you can just send the decimated one. Like if I took this decimated one here, where are you at? This one. This can go straight to print, but then I could also throw it straight into the Unreal Engine and it would appear right in there. This is only 1.2 million polygons. So you could definitely get this entire model here into game. And then if you wanted materials, you could try to do vertex coloring, but depending on how much, this is the decimated version. So it has quite a bit of topology on this guy that would actually support coloring pretty decently. But if you wanted to put like decals down here, you wouldn't be able to get that on the vertex color. Let's see what else we got here for questions. Yes, and as we got one coming here from AFX Winner, the export for UE5, which looks awesome, where they're just throwing the billion polygon model right into UE5. So we got one question too, is there a way to reduce the resolution of a subtool without losing the UV map? So you can do it with decimation. So if you come up here and use Decimation Master, there is an option to keep UVs, so you can definitely do that way. So that would work for any static props. So Decimation Master works pretty well for that. For animated objects, your best bet is going to be taking a model, generating UVs, dividing it up, and then projecting it. But because zero mesher is always going to rip the UVs off, and then Dynamesh is going to take them off. Anything with Z-Modeler is going to take them off. So your best bet, if you wanted to keep them, would be decimating, or basically working out a low resolution mesh that has subdivisions and then dividing it up and then doing your projections. For the tentacles here, for him, what I did was I just started with a sphere, and then I just used the snake hook brush with Sculptris Pro turned on. So we had a question asking about the tentacles. And so these, let me get out of the, make sure you don't have any subdivisions. And then I just took this and I just started dragging this out, if I can get my buttons right here, and just started making the tentacles like this. So I do this whole process of making these in the first part of the video we did with this Proko collaboration, and I'll put the link in the chat for you on that. And so you can definitely check that out, and it's in the first part of the stream itself. Contains how I did the... And so I'll go through that process. And there's a link there that will take you to the ZBrush calendar page. And on there, there'll be 3 links in which you can click. So the first, second, and third stream. And then you can also check out Scott's video too on Proko's site. So Boris is asking, do you find that preparing for SLA and 3D printing, the process is too destructive if you need to change the scale of the 3D model? So he's referring to this in terms of thickness. So yes, if I have a model that I know I have it a certain size and then I want it to be SLA printed, that's when the hollowing process would come in. And at that stage, you need a certain thickness for your hollowing. And so if you set your thickness initially to say 2 millimeters, and then you decide you change your part scale up or down, those walls aren't going to be 2 millimeters anymore. So definitely yes, I would size the mesh before I sent it for SLA printing or did the hollowing. So the examples I did with the hollowing that I'll show you guys here is I went through and actually did it at, I think, 2 millimeters, or actually it might have been 4 millimeters is what I hollowed that out at. But that was at the larger size too. So if I wanted to scale them down, then I'd have to change all that hollowing. But if you keep the hollowing separate, which I'll show you guys too, you can definitely keep it around and then modify it if needed. But for the most part, if you've got to change your size and you need to hollow it, you're going to have to change the size first and then hollow the process, because it's going to definitely change your hollowing on the inside. Another question, when blocking out the shapes, is it better to Dynamesh the entire form or use primitives to block out and then sculpt details? So in reaffirms that, it just depends on what you're used to and what you're happy with. So I'll end up, for this project here, I went through and blocked it out and with like primitives just to kind of get dimensions and sizes and scales. I also posed the model really early on because I knew I wanted it in a pose. So I posed very, very early on, and then I added just primitives to see where the silhouette was going to look like and where it was going to be on the mesh. And then I knew that all those pieces weren't going to be my final parts, so I went back in and then changed them and modified them. And for the different processes in terms of blocking out, like the horns and tentacles, I used just Sculptress Pro to block out. The kind of like the gun was all ZBrush block out. A lot of the stuff was primitives. Some of the other stuff was Dynamesh sculpted. Some was ZBrush. Some of it was the base model I did in Sculptress Pro first, then I ZBrushed the entire thing, then I added subdivisions to it, and then I posed it. So there's really no right or wrong way to the process. It's just whatever gets you to the result in terms of something like this. If you're dealing with game stuff, then you'd have to deal with base meshes and things like that because they probably have a system in place where you have to use a specific mesh for the engine to save memory costs. But in terms of this kind of stuff where it's going to be a static 3D print object, it doesn't matter. So Fabian's asking, do models always have to be an A pose or T pose to get them rigged properly? Or can we give them some posing on a model and then have it rigged later? So for the most times, if you give an animator, if I gave an animator this model and said, here you go, have fun rigging it, it's not gonna happen. I will have no friends. So that's the big thing with rigging, is that you have a bone structure, and the problem isn't the rigging itself, it's the weighting. And so the weighting, if you have your arms out and you have a bone structure inside your model, I can easily select this bone and tell it, hey, this set of vertices around this arm, I want to go to that bone. And so when that bone moves, your arm moves. Now, if this is posed and I have it like this, I can place the bone in there pretty easy. Like, you can definitely go and place a bone inside a posed model. But now when I come through and I want to go, hey, I want these vertices to be linked to this bone, now when I try to select anything in this area, I may also select stuff on the chest, I may select stuff on my face. So it's going to be extremely hard for me to go in and select those areas and then go, hey, assign it to this bone. So it comes down to a weighting issue is your problem. And that's why A pose and T pose are usually your preferred approaches. The A pose is going to give you more kind of natural stuff in terms of you're not doing like any complex like shape bends or anything like that. And you're not going to have a character that's doing like crazy motions. So if you keep them at A pose and they can rig them like that, and they're always going to have their arms down by their sides and they're just going to be walking around, that's perfect. If you have a character that's going to be doing, you know, crazy movements, you may want to get that pose where it is. And then in ZBrush, you can do your kind of test blend shapes to get your muscles and stuff going too, because shoulders are usually the worst candidates for everything because it's just such a large range of motion. And they occlude stuff, they clip stuff. If your character's doing this, you know, it could be going through your head. So there's all sorts of stuff. So Jupiter's asking, any best method to make flat shapes? Clarify what kind of flat shapes you're looking for. So there is so I'm in my bandwidth at my house is awful, so I have to go to an offsite basically to stream. So there's actually a concrete plant that's behind me, and so that's what you're kind of hearing in the background. If it's a busy concrete day, I apologize. Oh, the dragon wing, that's a good one too. That one's tricky because it's thin. What I'd say doing that is just be very careful and just take like a piece of plain geometry and just kind of pull it where you want to go, and then just kind of manipulate it. But that's a whole kind of, anything thin is oftentimes a little bit tricky because of the thickness. You have to like zoom in or control it. There's a backface masking option that's in the brush auto masking area over here, which you can turn on, and that will allow you to make sure you only sculpt on the front side, but it's still tricky with wings. Wings are not easy things. Characters using Z, it should, so another question, does posing a character using Z-spheres or transpose keep the UVs? If your base mesh has UVs and you pose it, it should keep it. Don't quote me on that, but I believe it should. If not, you can yell at me, but it should keep it. All right, so back to this. Okay, so we went through and we closed all our parts, and so now we have our kind of solid models here. And so I can open up my version here. And then at this stage, what I end up doing, I'm gonna have to clear my cache here. One sec. Let's load this in, and then I gotta delete some files. I got too many files in ZBrush. My project's getting crazy. So if you ever want to delete files in ZBrush, if you come over here and select these, down at the bottom there's a delete all, and that will clear it out. If you don't have anything you really like over here, you can also copy the one that you may want to keep around. So you just select it and do copy tool, and then just load in another project, like this sphere here, and that'll clear out all your tools over here too. And so that's another way you can kind of get rid of everything, and then you can paste back in the tool you wanted to keep. But you could also, if you save them as ETLs, just come in and load these back in. So this one, let's see what this one is here. Wait for it, wait for it. All right, so this one has all his kind of parts fixed. So I went through and I closed up all the holes, and he has all the things filled. So he should have none of those gapping that was appearing. He's not having those any areas where there's a hole and then it's generating this whole inner structure there. So he was definitely cleaned up through that entire thing. And now in terms of the process, what I do is I'll start taking this model and I'll start breaking it down into chunks. So for the printed version of himself here, so this mesh here, let's go back to my large camera. I have him in those different sections, right? So I have his gun that goes with his arms, because that could pop off. I have his boots that are attached. I have his pants that are attached. I have his chest that goes as one, and then I have the tubes. So he was only, he's not a crazy amount of parts, and I could have had the shoulder pad be a part, I could have had his helmet be a part, but I didn't really require any of that, so I basically broke them up so that if I was wanting to paint them, I could paint them easily. And also the size that I'm limited to on my print bed. So the MakerBot I have has a 7-inch width kind of print bed, and so the height I think it's 5, so I think it's 7 by 5. And so I knew that I wouldn't be able to I can't get him fully printed on the MakerBot Replicator 2 that I have. He does not fit in the bed. So I had to break him up into chunks that way too in order to get him to print. Another thing with the printing process too is when you chunk a model up or try to get it to break it into parts, try to use areas of transition on your model that are covered by where transition areas really happen. So breaking off of the gloves here, there's a clear transition line right through here. So I was able to break that off, and now that becomes a transition line because it is a transition line. Same with the boots. I have them all where the boots are meeting the pants, and then the division I have for the belt to the topper torso, that's another good division line. And then all these hoses, I have them breaking at the little part on the back. So when you're slicing up a model or looking at it, I wanted to make sure that it has parts of the mesh that are looking where those transitions happen, because those transitions are going to hide those seams. So I didn't want to put a seam line directly in the middle of the gun. I don't want to put a seam line directly across the character like this, so it's very visible. I want to make sure I try to hide those as much as possible. And so with that, what I did is I'll start taking my parts and start merging them together to make little assets. And so for these here, the first ones I'd come through and do is I'd come through and do, say, just the gloves, and then also the boots. So we're gonna do the gloves first here. And I just take these, I make sure they're the only thing visible in my scene. This is still broken up into multiple parts. So you can see they have all the kind of different glove parts here. So that's 12 different subtools making up the gloves. And I'll just come down here to the merge area here, and I'll just do a merge visible. And this is now going to take this, and now it's going to take them and put them at the top here. So now I'm basically building another tool file here. And so I work oftentimes in multiple files. I won't keep everything in one. So I'll have like this file here, which is my main with all my different parts. And now I'm making a part that I'm just going to use to merge these things together and then slice up to get subtractive shapes. So gloves, and then I'll go and we'll do the belts. We're gonna do those too, so I'll do those. Let's merge those. And right now I don't care if they just come up here, they can just come up here and live. The size is gonna remain the same as what I have in here. I haven't scaled anything yet, but it's gonna stay relative to my original file. So when I do a merge, it's gonna make a new tool, but these are all gonna be relative in size to my original one here. And then we're gonna do the boots, and merge that as well. And that should give me a good start on these. So now I have these separate tools, and I just want to append them, make a new file here. So I'm just going to append in the belt and append in the boots. And so now I'm starting to make this little scene here. And as you see on each of these parts, when I modeled them, I used cylinders for these areas here, and I created these kind of apparatuses where the glove would go on and attach. And with these, I have these set up so that they now can, they give me a clear transition line. And so they give me a clear transition line on the model, and then they also give me this nice area that I can use to cut from other models, right? So I could use this to, in a Boolean process, to subtract, and this is gonna end up giving me a flat surface. I'm gonna get a flat surface on the boot. I'm also gonna get a flat surface on the belt. So they can also become these nice cutter areas that I can use to cut these other parts of my mesh. So now let's, as an example of this, I'm just gonna go and I'm gonna grab the chest. And with the chest, I know I wanted the chunk to have the chest. It's also gonna have the tentacles. It's also going to contain the helmet. And then it's also going to contain the body. So this is one whole chunk here. Now you'll see that this entire part here, it's kind of overextending. So you can see I have legs, which would go into those boots currently. I have these kind of caps on these arms here that would go into the gloves. And then as you can see here, this whole entire area would go through that belt. So I know I need to split this up a little bit more, but first I need to kind of merge it together. So I'm gonna take this, I'm gonna come in here, merge visible. It's gonna give me this tool. And now if I come up here, I have these parts, and now I'm going to append in my main body here. And now with the main body, I'm gonna start subtracting stuff off of it. So the things I know I need to get rid of to set up these keys is I need a split between this glove and the arm. And so to get that split, I'm gonna take my body here that's merged like this. I'm gonna move this up to the top. And then I'm gonna take the gloves, turn those on, and I'm gonna set those as subtractive. Make sure the eyeball icon's on there. And now I should have this result, right? So I have that main body and it's now subtracting those gloves. And then for the boots, I can do the same thing, turn those on, turn to subtractive, and now I have those boots being subtractive out, right? So that is giving me those parts through there. Now the next part I have is the belt, so I want to do that as a subtractive part 2, turning that on and subtracting. And now you can see I've just took those one parts and I'm just using them as cutters. They're not my final assets, I'm just using them to subtract parts. Now you'll see as I rotate around this model, there are some kind of artifacts that are kind of floating out. So you can see these ones here, where the cutting itself isn't cutting fully from the mesh. And this is okay at this stage, because basically as long as it isn't attached, after I process with the Boolean, I'm able to come in here and do an auto groups, and it's gonna give me the parts I want. So I'm able to get the top part, and that's pretty much my only concern right now. Like I want this top part of the body, and I want that surface where that belt subtracts from, and I want a surface where the arm subtracts from. And then the pants is just gonna be a byproduct here, so I can even turn those off right now and just get this as my mesh. So now I combine these together. I'm just gonna run the live Boolean on here. So we're gonna come down here, activate Boolean. By default and habit, I turn on dynamic subdivision all the time, just in case I have any parts of the model that I'm using the Boolean that doesn't have dynamic applied. Just make sure that's on, and then I'll make sure that accepts that process. These, since they're already merged, they're already gonna show you if you forgot to turn dynamic or apply dynamic, because when you do a merge, the dynamic one's gonna go back down to the undynamic version, and then it's gonna merge. So if you have any areas that look tessellated, go back to your original model. Definitely apply the dynamic for those subtools and then perform the merge. And so we're gonna process this, and then we're gonna see if we can get questions while this is happening and my machine doesn't go crazy. Let's see here. So Stefano is asking, let me know if my voice goes crazy while I'm doing this, because I'm definitely processing with the Boolean system here. So if I start getting robotic, let me know. So Stefano is asking when he duplicates a subtool or moves the copy, it's offset. So sometimes this will happen if you have not saved your file or you've started with a primitive. So if you've come up and started with, say, like a cube primitive, and then you've taken that and you started working on it, it hasn't fully locked in the position. So if you see that happening, save your file out just as a ZTL and then just reopen it and then try duplicating and see if that clears it up. But there has been some reports we've had where users ended up getting that. I personally have never had it happen, but if you have that happen, save the tool out and then try to reopen it and see if that works. So Mary's asking, does subtools kind of intertwining in 3D printer make it different? So the thing with this is if you have kind of intersecting meshes, some printers are going to fuse them together automatically, some are not. So for the FDM printers, I need to go through and actually weld them and make them correct, because if you have two shells for an FDM printer, it'll actually print the two shells and then they'll separate. So sometimes with FDM printing, you will have to make everything solid all the way through. And that sometimes makes a little different there. And I see Pro 4210 is bringing up how he made his dragons. Thank you. So Maple Cliff is asking, could you split the machine gun to clip it onto the hands, or that would be too heavy? So I have it where it's in both hands, so I have the hand and the gun, and it itself in the final print itself isn't that heavy, so it doesn't tip. It's really lightweight as an FDM part, so there's not a lot of infill on it. I also have the entire barrel, you're not gonna be able to see this probably, but this is hollow all the way through. So this is hollow back to here, so that's also adding more light weight to it. And then the infill on this mesh isn't really heavy, so it's fine in terms of what I did to it. And I have it attaching the hands purely because I could have segmented it at the handles. I could have segmented on this handle. There's a bunch of different ways. I could also have gone through and say just put a hole and then used wire in these two aspects here. So it really it's up to preference at that point. But I just kept it attached to the gun itself. So the gloves actually are attached to the gloves, to the gun. So then I could just detach it and paint it if I wanted to, and then pull it back. Another question, when appending a new subtool, I've seen people append their new subtools at their current location instead of the default location. So with that process, you could use an insert mesh, and then if you have an insert mesh brush enabled, if you click on any of those parts, it will go to where the gizmo is. So that might be what they're doing there. So if they move the gizmo to a location and then they click an insert mesh, it would end up replacing the part they had selected and it would snap to where that gizmo is. So that could be what was happening there. So Lexter is asking, if I have a 10 centimeter brush and I want to print it whole, how many poly points is recommended to decimate? So what I usually end up sending stuff to decimate pretty much globally, everything, is I'll go to 500K, 250K to 500K. And that's usually my go-to. So if you take the model and basically decimate it down and then on your screen, size it up roughly to the size you want to print at. If you can't see the triangles, you're definitely not going to see the triangles on a print. And one thing with the print too, depending on the resolution of your machine, oftentimes you'll see more of the striations from the print than you would any of the geometry on it. So I usually take meshes, my usually average default is 250K, and that's one of the decimation options right here. So for this entire model, when I sent him, I sent his torso at 250K, his gun at 250K, and then I ran everything else at 150K, and then for the little wires on the back, which were this big, I sent those at 75K. So you just don't want it too heavy, because when it gets into, say, that application for the slicing, if that's an OpenGL application, you're gonna have to have a bunch of RAM to import that model in, and so it could be extremely sluggish when you're trying to rotate the prints and do things. And then to slice it could also take some time. But in general, you can decimate a model down pretty low and it's still gonna hold the sculptural details. And if you ever downloaded any 3D print files from, say, like Thingiverse or stuff like that, oftentimes they're all facetted, like they don't even have smoothing. And when you print them out, just the printer itself sometimes will have enough where it's gonna smooth surfaces a little bit. So just decimate it down, get it so it works. I mean, if you could always decimate it to the maximum too, like 1K is probably, or 1000K, 1 million points is probably the maximum I've ever sent anything for 3D printing at. Because it's just, if it's small, like 10 centimeters, you're not going to see all that detail anyway. So save the file to a size that's lightweight. Like you don't need to send 50 billion polygons for something you're printing that big. Until the printer technology gets better and better, then maybe you'll see those details. But right now, it's you can decimate down. The question here, do I use Maya and Blender, etc. for hard surface elements? I do all my hard surface stuff in ZBrush. So everything on the character here was all 100% ZBrush here. Back in the day when I was doing game stuff, I was primarily using Max. And even with that, I'd create my model I'd create like a subdivision cage in 3D Studio Max, and then I bring in a ZBrush and do all my hard surface in here. So definitely, I've always done a lot of the hard surface work that I do entirely inside of ZBrush. So one question here about plates for, say, like crabs and stuff. Trying to think of like I guess for things on that, I'd say look at reference from District 9, had some awesome stuff in it in terms of that kind of establishment. I think they had some ZBrush models, and there may be posts on how they did it. But basically, you just mask an edge and then inflate it, and that would give you that kind of offset, and then you go back in and sculpt those details there. I don't think there's any really tricks per se, other than it's just sculpting. So there may be, I don't have any other, like, I mean, it's masking edges and then inflating and then taking a brush and running it across, which will give you that nice kind of plate. And then it's just the overlapping aspect of it. So for my PC here, I'm running on a extremely old laptop here. So it's not the fastest thing in the world. So it does take a little bit longer for me to process things. I'm also streaming, and I also have 2 monitors hooked up and everything else. So this one is a old i7. Here, let's do some DXDIAG. See if we're gonna pull it up here. Let's give you my computer specs. We'll give you the full specs. There we go. So this is running a Core i7, and it's at 2.3 gigahertz with 8 CPUs. So it's only a 4-core machine here, and I just have 16 gigabytes of RAM on this one. My home machine's a little bit faster, but this is my travel machine, and it's an old MacBook that I run boot camp on. One other question was subtracting when you calculate the space of the glue thickness. Yes, you can. Oftentimes I don't, especially with FDM machines. You're already going to have enough offset with the printer itself, so at that point it really doesn't matter. The Form Lab stuff, you'll be able to get like the Form 2, you can get more precise in there, but I usually err on the side of larger versus not, and basically most of the time it works out fine. If you're doing stuff for really precise stuff, then yeah, you'd probably want to calculate glue thickness and everything else, but my stuff's mostly just making little toys and random collectible things. So Dave Monograph is talking about quad mesher. So that's the same thing as ZBrush. So ZBrush is the first version of that. So Maxime Exocide is the one who did the ZBrush. And another question, is there a way to center one subtool to another? Also, is it possible to attach one subtool to another by 2 faces? You cannot attach or position 2 meshes on top of each other unless you use an insert mesh brush. So you can take an object, turn it into an insert mesh brush, and then you can draw it out on a surface, but you can't say have a cube and then have this cube and you want to smash those 2 surfaces together. There's no way to do that currently inside of ZBrush. And to center a subtool to each other, you just would have to know its positioning. So if you wanted to do that quickly, you could send through macros, send both of the subtools to the 0 of the world, and then you could do something like move them using this transpose all selected subtools, and then that would allow you to reposition it. But in terms of positioning stuff, the Gizmo 3D doesn't store a position with the mesh, so you can find the bounding box in the mesh, and you can find the center of the bounding box, but there's no real rotation data or position data based on the Gizmo 3D and your subtool, so you wouldn't be able to snap them per se to each other. All right, so here's my merged body here, and it's into those parts. I'm gonna take them and put him into my other file here. And so now I have that along with my other parts here. I'm just gonna isolate him quick. And with him, I just wanna do a quick polygroups. So polygroups, autogroups. And this is just going to apply a polygroup to those areas. And you'll see this is gonna give me a different polygroup for every island. And you can see as I cut out this part here, this is now its own polygroup. And so I can hold Control and Shift and select it, and all that other stuff is now gone away. And I'm left with just this part. So then I go to Modify Topology and I can delete Hidden. And now I have that part of my mesh done. And so now I have that upper torso part. Let me turn off my legs here. So I got his arms and I got his upper torso. So they're going together. And then I also have the belt, that connection point there. So that is all good to go in terms of that area there. Now I'd also want to come through and, you know, make, if I had anything that attached to these, which I just haven't cleared out right now, there's another good set of connection points, which I'm going to put the hoses in. But that knocks out the body portion of that. And then for the rest of this, I just kind of repeated that process. So for the legs, what I did was I went back, and I'll show you this one quick, and then I'll jump ahead here. So I'll take the body, and then this has got the legs. This is pretty much all the legs I need here. So I'll make sure that's merged, get that subtool, and then I'm gonna go back to my little build file here that I'm creating, append that in, there's that there. And now with this one, I wanna break the legs off, and I just wanna attach the legs to the belt because I've already got the cut section for the belt. And then I wanna go through and I wanna subtract the boots, and that's how I'm gonna generate the leg version. And so with this, I have that upper torso, but let's say if I take that and I try to subtract the upper torso, turn my live boolean here, you see it's gonna give me this kind of stuff like this. Because that upper torso is sitting in the same position as parts of my body, which consists of those legs, and it's the same surface area there pretty much. So if I use the boolean on it, I'm gonna get something like this, and I don't want that. So I could inflate this part of the mesh and make it larger, and that would, you know, get rid of that offset and it would allow me to subtract it. However, now I'm modifying that mesh, and so I'm not gonna get a clean cut from where it hit the belt area, right? So instead of doing all that, what I'm gonna do is I'm gonna go to the body here, and I'm gonna first apply a polygroup to everything. So this has still got the polygroup coloring from the merge geometry. So I'm just gonna hit Control W and give everything a new polygroup. And then I'm gonna rotate this so this belt is laying pretty horizontal. And this is another thing that I like to do when I just model stuff for 3D print, is using these cylindrical objects to kind of make belts or different structures, and also making them wide enough where you have room for error. And so what I want to do now is I want to break this leg from the upper top. And so instead of doing a subtraction process or a boolean process, I can just slice it and then fill the hole. And so I'm going to take the slice curve here, and with the slice curve, all I need to do to slice it is slice it somewhere in the middle of this belt. So as long as the slice happens in the middle here, if I cap this hole, the belt is gonna have enough thickness there to establish that connection with the bottom of those pants, and then I'll be able to use that as my object. So I'm gonna hold down Control and Shift and drag this out. And the slice is always gonna shoot through no matter how short this curve is. So this allows me to line it up perfectly where I want it. And you see when I slice, it's gonna slice through, and you can see it's gonna go all the way through. So it's sliced over here and sliced there as well. So just one little thing with the slice. Now after I have that slice applied, I can now have my pants. You can see I've got that nice line going all the way through. I can hold Control and Shift and select that. I can then now remove these excess parts I don't need. So I'm just gonna get the select lasso, drag this out, hold Alt to remove those. And now I'm gonna delete hidden to get rid of all those parts through there. And then now I wanna make sure I wanna close my holes. And so the reason for closing holes is that I won't be able to perform the Boolean process if I don't have watertight meshes. So I'm just gonna come through and close that hole there, and that's gonna seal up those pants. And now you'll see that the belt is gonna fit nicely in there. It should all be intersecting all the way around. And now I have a clean top to that belt, which is gonna merge onto my main body here. So that is the process there for that. And then now with my pants here, I just need to make sure I have my belt selected, turned on. I wanna make sure I subtract the boots, so turn that on. And then I wanna make sure that I add that belt. So I've got my pants, I'm adding the belt, and I'm subtracting the boots. And this should be the result I'm gonna get from this Boolean process. And then I'm gonna come over here, go to Boolean, and make Boolean mesh. And this will process here. So for questions, so I have a whole little thing that I did on the ZBrush on how to go through and generate a tire. If you do a YouTube search for Z Classroom Live and my name, or Z Classroom Live and tire, you should get a little video that's going to come up on YouTube, and you can watch that. And it's another stream just like this, and I go through a lot of the ZModeler processes and go through the entire thing of creating a tire. Definitely check that out if you want to find information on the ZBrush. Now with the Boolean process here, you'll see that I got this little message that pops up on this one. And it's saying that it succeeded, but there may have been errors. Now, you may get this oftentimes because the Boolean system wants you to know if there's going to be any trouble with your mesh. But most of the time, if this comes up, the Boolean system is robust enough where you can just ignore it. And so unless you're going to process the model again with the Boolean system, that would be the only time you really need to like kind of worry about this. But with this mesh here, this is going to be fine. It gave me a result. And if I come up here, I should have a result model. And you can see it still looks okay. But basically that error came up because it was probably one edge that may have been like really thin and it was cutting through another edge and then saying, oh, that's not going to give you a clean Boolean result. And so if you were doing something really low res, you'd notice it. But with something like this, with this many points, that issue that just happened or wherever it was probably related to that closed holes I did, is never going to be visible. So it's definitely not an issue right now with this mesh. So you can just kind of ignore that there. But if you want to go through and find out what could have possibly caused it, basically if you take your mesh, the ones you were using for the Boolean process, you go to geometry, down here at the bottom there's a mesh integrity. In here you can do a check mesh and then you can do a fix mesh, and this will come through and tell you if there's any of those shared edges or weird edges before you process with the Boolean. Oftentimes when you click the fix mesh, if it does the fix, it may remove your closed holes, so you may have to apply the closed holes again. But there are ways to kind of repair your mesh too if needed, and they're in those modified topology there, or mesh integrity area. But for this one, this model is good here. So I just want to merge it back to my scene again. So take that, pen this in, get my merged version, and then I'm just going to make sure it's the only thing selected. Once again, you'll see I had this little part that's off stray in the corner here. So I want to do that, auto groups again, select the legs. Oh, make sure I'm not in select lasso. That would be good. And that should hide any of those little anomalies. And now we can go to modify topology, delete hidden. And now that is good to go. And then I can get rid of my old legs here. And so now I have, look at my parts here. I've got this part. I've got the upper part. I've got my boots. And then I've got my gloves. And with the gloves, I'd attach them to the gun itself. And then I'd go through the same process and generate the wires. So we're gonna jump ahead here to all the parts here. Yes, so that little piece of geometry that was floating was part of the boot. So that boot there, I didn't have it clipped out fully. So it was just generating that little island, and so I just deleted it. So Barack is asking about the keying stuff. So would you use the same Boolean key for negative and positive, or the negative slightly larger? So it depends on your printer. Once again, for the model I did here, I made the negative ones, I made the positive ones smaller than the negative ones. So I made larger negative ones, and I'll show you guys how to do that. And one thing I don't know if I installed here. Oh man, I'm gonna do an off-screen tangent here. So two things. That I'm gonna end up using, and I did not grab them. So if you ever want a bunch of plugins for ZBrush that may be very helpful for you, if you go to the Pixologic Resource Center, in here there's a whole bunch of different plugins. There's often updates for the standard ones too, so if there's anything that's been patched, maybe you've ran across something and then you've submitted a support ticket, sometimes there is updates to it. So you can see ZBrush to Photoshop, which ships with 2020.1.3 has had a patch, so there's a download version of it. So you can find upgraded or updated versions to the plugins as well. But then below all the ones that ship with ZBrush, there's all these other plugins here, and this just comes out of my madness and usage of ZBrush. And so ones I want to grab today is I want to download this quick scaler. We're going to save this. And I guess that's just putting it somewhere. And then I also am going to grab the Dynamesh Master. And you guys are gonna get maybe a little tutorial here on how to install plugins, because I forgot to do it. Let's find out where these downloads are. All the plugins. All right. All right, so this was on the Resource Center, and I've just downloaded 2 plugins here. And I'm gonna show you guys how you can install these. So these are the 2 plugins I downloaded. So I got Dynamesh Master and Quickscaler. And so if I open these, it's gonna open here in WinRAR. And then in here, I've got an install and a README. So if you're installing one of these plugins, I definitely recommend coming through and reading the README file, because this is going to tell you how to install it. Oftentimes, if you don't have a plugin, if you have a plugin and it's not working, it is 90% of the time installation. So in here, it'll just tell you what you need to do to install this. And basically, all these plugins, if you download from the Resource Center, should have a little list of where the plugins should reside in terms of their folder structure. So you can see here, they should all be in this zplug64, and then you should get a list of their folder and what files are in them. So if you ever have any issues with plugins, these little README files that are with the plugins will help you tremendously in finding out where to install them. And so in each of these zip files is also an install folder, and if I open that up, these are the data files for the plugin. And these just need to go to your program files, Pixologic 2020, Z Startup, zplug64 folder. And then in here, I just need to take these and copy them over. And then we'll do the same thing for the next one. And after those are all in there, I now just need to restart the ZBrush. So let's do that quick. And there's no picture of the print while ZBrush is restarting here. Let's see other questions here. Just some guys asking, was the little Boolean piece caused that Boolean error pop up? No, it was more than likely the closed holes thing I did with after the slice. So one of those little areas in there, when it closed holes, it probably did something like this, where it went through another polygon, and then that made a sliver, and then that was probably what was causing the Boolean pop up. That little floating piece should be solid through where it was, so it more than likely was the closed holes for the pants, not the little floating piece. The little floating piece would probably look like Swiss cheese if it was that one. All right, tubes done, all parts merged. Okay, I think this is the one. Drustmeister's fine. I'll take that nickname. Another question, do you adjust your perspective and what angle of view do I use? So most of the time I work in orthographic, especially when I'm doing 3D printing stuff. If you go to the draw menu up here, there's camera settings up here. So 50 is what the default is, which usually stays. But if I render anything, I usually always set to 35. It's usually my go-to for kind of rendering. But if you have perspective on, you go to the draw menu and you can change this up here and change your perspective. But default will be set to 50 inside of ZBrush. So this one is, are these all merged or are these done? All right, so these are all the Boolean versions. So this is after I've gone through and I've created all the parts. And you can see these are the parts I created. So this is that same process I did. I merged them together. I set up those different subtractive elements and then generated the results. So I have a body, I've got the boots, I've got the bottom area here, I've got the tubes, I've got the hands and the guns, and then the little buddy, right? So the little buddy has not been subtracted yet, so he's just kind of floating there. I just made them all one single mesh, just watertighted them, and then he's just sitting in the same aspect, but he hasn't had any of his keys carved out. So now at this stage, I need to generate some keys. And for this, the process is fairly simple. I'm gonna go through the keys first and generate those, and then we'll talk briefly about the hollowing system too. But definitely, if I do this kind of process in general, I'd usually take the mesh, break it up into chunks like this, and make sure they're all watertight. And then after they're watertight, I would then go through and add my keys. And then after my keys, I'll go through and do hollowing if it's necessary. And that's kind of the functionality from it. If you do your keys after the hollowing, you may find out that you need to re-hollow. And so that's why I often do the keys first and then do the hollowing later. You can also get away with sizing and stuff too. I usually do after the keys, sometimes before the keys. it depends what you kind of want to do with it. So at this stage, let's just go ahead and we'll resize them too. I'll show you that, and then we'll do the keys. So with the model here, he has all his parts and he's set up basically where everything's going to be laid out. And now before I do the keys, because say you want to have a certain thickness of your keys, it's probably good to scale it before you do your keys. So I'm going to take this mesh and I want to resize him. Now at this stage, I haven't done anything with size. I started with a sphere, I sculpted the entire mesh, didn't care anything about size up until this point. So to resize him, the process is pretty easy. So in the Z plugin tab here, this was not one of the plugins I just installed, but a plugin that ships with ZBrush, and that is the Scale Master plugin. In here, we first need to click the Set Scene Scale, and this is just gonna allow us to set what dimensions we want in here. And you'll see the default dimensions here are pretty big. So when I mess with that sphere, if I choose inches, you can see it's 77 inches, right? So this thing is massive right now in terms of scale. So I'm gonna choose millimeters right now, just as the default. And then in the Z plugin area, I'm gonna go back to Scale Master. And then I'm gonna click this new bounding box. And what this is going to do, it's going to look at all the subtools in my scene. It's going to give me a bounding box around it. And with this bounding box, I can then resize that bounding box and resize everything else in relation to it. Now with this, before I do that, I want to make sure they don't have anything that's going to be making the bounding box crazy. So you can see I have a dummy object here as my first subtool. And this is when I save as ETL, it's going to rename this rather than renaming anything else in my scene. If you save project files, you don't have to worry about this, but I save a lot of ZTLs. And so I'll always have a dummy object that's the top subtool so that gets renamed and then nothing else gets renamed. So with this, with the star, you can see it's automatically going outside my bounding box. So if I create a bounding box using Scale Master, it's gonna go all the way around. And I don't want it to go all the way around, I just wanna go around the object itself. So I'm gonna scale down this star and then just throw it in the middle of the mesh. So now that star is out of the equation in terms of the bounding box. And now I can come up here and do new bounding box subtool. It's going to create just a simple subtool and it's going to fill it around my model. So if I turn on transparent here and turn off ghost, you can see that everything of my model is now fitting in this bounding box. So now that we have this bounding box, I can now resize this bounding box and then make everything else go with it. So I can come back up to the Z plugin tab. In here, I can set the size I want. So currently I have the bounding box kind of set. So I can go to inches, I can do sliders to subtool size. And you can see this model is massive. So we're still at 86 inches is what it's coming out now. So if I exported this out in generic units, I'm gonna get a millimeter value that represents 86 inches. So that's a massive, massive piece. So I want this to be at 8. So I'm gonna type in 8 on this. And then if you're using any sliders in ZBrush, make sure you press enter after you type it in. This should now lock it in. As long as I had this little ratio on, all the other values should go at the same ratio. And then I can click this resize subtool and make sure I have the all button turned on. And this will go through and it's gonna resize everything here. And when this is done, if I zoom out here and you see it's taken everything and it's just resized it, you pretty much won't see a change other than that if you turn on your floor now, your floor is probably massive, right? That's the only real difference here. And then if you go Z plugin tab and I do sliders to subtool size, you can see it's gonna now return that bounding box at that size. So that's pretty much the usage of the bounding box. I can get rid of it now. I've now gone through and scaled my mesh to that inches format there. Now the next thing you want to do is if you've done a really large offset in scale using Scale Master, like it went from 86 inches to 8, that's a big offset. And so you can notice if I zoom out and turn on my floor, he's very tiny in the ZBrush world. So what I want to do now is I just want to unify the entire model back to the ZBrush world. It's still going to keep the same scale it has currently, but just going to unify it so ZBrush is like, hey, this works better, this stuff works great. So there's a certain size, internal size that ZBrush likes, and then there's an export size. So there's two different variables in here. And so to do this, I just go back into Scale Master and there's a Scale Unify. This is now gonna run through this little scaling process one more time. It's gonna make your model look like a embossed mesh for a little bit here and then grow back out. And then after this is done, now if I turn on my floor grid now, it should look more normal. So now I've just gone through and resized everything. And that's pretty much the process for resizing. So I usually take the mesh, finish with the mesh, generate a bounding box, rescale by the bounding box, and then rescale all the parts. And so now I have this model all sized. So now that I have everything sized, now it's time to start doing my keys. And so with the keys, I try to keep my keys as simple as possible. And as simple as possible, I mean, I basically just use a box. So I don't try to go out with, you know, crazy things or like weird cylindrical stuff. I usually do a tapered box. And for this, I'll come over here and I'll just append in I'll just come to the top here and select the Polymesh 3D star. I'll go to the Initialize tab here, and in here I'll set my resolution to 111 and then do Q cube. And then now I have a cube like this. And with my cube, I want to just mask part of it and then go to the Gizmo 3D and make sure it is centered on that unmasked part, and then just scale down a little bit. And this is what I'm going through here. I'm just looking for this little tapered cylinder, right? And this is the lowest polygon possible. So it has, you know, just 6 sides here, and it has a taper. Now with this, I want to turn this into a brush. So I'm going to come over here to the brush palette. I'm going to go create, and I'm going to create a new insert mesh. And this is now going to make me an insert mesh brush, and it just has this part in it. Now if I take this part and say I drag it out onto a surface, this is what I'm getting. So this will allow me to draw this out, but you'll see it's sitting on the surface when I draw it. So it's not interpenetrating or digging into the surface. And I want this to be into one side of the mesh and then subtracting the other side. So I want it to go inside the mesh. So I'm gonna go to the brush palette over here with this insert mesh brush selected, and go to the depth area, and I'm gonna change my embed value to 0. And so now when I draw this out, you're gonna see it's now gonna be sitting into the surface there. So it's no longer sitting on top, but it's now sitting in. And now you can see that I can quickly come through and use that to make keys. So I'm gonna go back to my body here, and I'm just going to frame him. I'm just gonna make some quick keys here. Now with this, you wanna make sure you're kind of clicking on a surface that's kind of flat. So you can see as I draw this out, it's gonna draw that key right out of the surface there. And it's also going to be embedded into the model. So it has a connection with the surface I'm drawing it out to, and it's also sticking out the other side. Now with this, after I draw the first one, I'll come over here and I'm going to split this off. So I'm going to split unmasked points. And this is now going to give me that key as its own subtool. And now with that own subtool, I can now come over and I can use this, and I can draw these others out, and it's not going to be drawing on the mesh I had selected, but rather the one with just these keys. So I know all these are going to be positive, so I'm going to draw these out and then draw one over here. Now one thing nice about keeping this primitive this low is that now I can modify this. So oftentimes if you do keys, you can do them this square way and it'll be fine. But the problem is if you have an object, say like a head, and you put a square thing on it and the surface is flush and you've got the head and it's going to the square. If you pick that head up and you rotate it this way, it still fits in the hole. If you pick it up, rotate it this way, still fits in the hole. So it gives too many points of orientation based on that key. And so if you have a key that's a square and equal on all sides, that key can still fit in that hole at a different angle. So it's not only fitting at the hole one way, it can fit the hole at least 4 ways. So sometimes that's bad, especially if you're trying to get precise alignments on objects. But what you can do with this as this low resolution subtool is if I activate the Gizmo 3D, you can see now I can manipulate these keys. Well, let me just get this one selected here. And I can do something like this, and I can change that offset. And since it is that low resolution mesh, I don't have to worry about it distorting the key. I don't have to worry about changing it because it's just those 6 faces. And no matter if I push or pull or squash or stretch, I'm not gonna get any overlap. I'm not gonna get any weird catch points. I can just modify it and make it really nice. And then the other bonus of this is that after you have these keys created, you can now apply dynamic subdivision to it. So what I'll do is I'll take this, I'll turn on dynamic subdivision, and then I'll activate QGrid. And I can now control the bevels of these keys. And this is all still non-destructive right now. And so now I can determine, well, I can just put a little slight bevel on it to make sure they fully, don't jam into those holes, or just give a little more relaxation to that fit. And so I can just come over here and mess with these, and I'm not having to change the topology. It's still those low resolution squares. So if I need to come through and say, resize this one over here again, I can easily do that. If I want to make this one different, I can just select it, and then I can resize that quick. And so you can play with the keys a lot easier using this approach than making some really complex type piece of geometry. And so now I have those keys set for that part there. Now for the next part, so I'd go through and I'd add these keys to all the areas where I want the positive parts. So I know his legs here. This one, I don't want one there, but I do want positive keys here. So I just do the same process, draw out one of these, then I'd split it off. Then I'd take that one, and then I'd add another one over here. And once again, you can mess with the rotation when you're dragging these out. You can also scale and skew and distort these. And then I'll turn on dynamic and I'll adjust the Q grid and change the coverage. And that's the keys for his legs. Now at this stage, what I'd end up doing is I'd go through and start subtracting these keys out. But before I do that, I want to make a duplicate version of these keys. So right now I'm just making positive keys. So I go all the way through and make all the positive keys where I need them. So that's the legs, it's the upper body type. Then I also have the tubes. I put keys on all those tubes. And then I'd now go through and I'd take these and I just rename them. So this is, why this one's doing weird stuff here. Where'd my key go? So I take this and I'd rename this one as, say, subtractive, or this is positive. We'll do this positive, we'll do this subtractive, we'll do this subtractive. And then I'll duplicate it. And on this second one, I'm gonna want this to be positive. And this way you can go either way. You just basically want that offset between the two. Now there's two ways you can do this offset. So with this simple shape, the easiest thing to do with the offset here is if I have both of these on, I don't know why this one had a hole in it for some reason. I messed something up here. Messed something up. Is if you have both of these on and I have ghost turned on, since these are so low resolution, what I can do is I can simply come down to the deformation area and use an inflate. And when you inflate, it's only inflating those 6 sides, and so it's going to scale that precisely. So it's going to scale it to that certain effect, and it's going to just collapse all those edges. You're not going to get any distortion, just going in and out. Now if I didn't mess up this one in the middle here, that one would also be doing too, but this one over here inside, so you could see how that offset is happening with the scaling. Now another option you have is there is this plugin called Quick Scaler. And this is the one I downloaded. And this one has a percentage option, a millimeter, and an inch. And what I can do with this, if I know I want my keys to be 10% smaller than the other part, is I can make sure I'm on the ones that I want to be smaller. And then I can just show one of these. And then I can come up here to Z plugin. I can say, let's decrease that by 10%. It's going to decrease it by 10%. Go to the next one. Let's decrease that by 10%. And then let's go to the next one. And then let's decrease that by 10%. So now I've just gone through and I've decreased all those by 10%. And so they should now be 10% smaller than the positive keys. And so now, after I have my positive and generated scales here, you can see this is my mesh. And he's got all his different parts. So we got body type, and then you see I have the positive key and then the subtractive key, and the subtractive ones are a little bit larger here. And so I'd go through and process with the boolean now. And since we're running low on time, we're going into cookie show mode. And so I basically process the subtractive one from the parts that I want subtractive, and then process the positive ones for the parts I want positive. And then these end up with, I don't know if I load the right file. Give me a second. Because I still want to show hollowing. I'm at the end here. I don't know if I'm gonna get to hollowing. Maybe picking this up next stream. Okay, all keys clean, all keys hollow. All right, let's see what this is. And then see, I have now this part with those keys. I've got the boots with those keys, legs with those keys, gun with those keys, tube with those keys, tube with those keys, and The little buddy, I just ran him through and he didn't get any keys, he just got a subtractive. So he just has these little areas that are basically, I made sure he had parts of him including the chest area, so that when that happened, it just subtracted those parts out. So he just has these little rough areas and he basically just fits right on top. And he actually fits, you know, really well on his mesh. Let's go to large. So if I sit him here, you know, I can wiggle him around, I can move him, he's not going anywhere. And he just kind of fits really snug, like he doesn't slide. So I just had enough interlapping parts that he ends up fitting there. And then I could put a little some super glue on him or some crazy glue and he'd fit right on there perfectly. But I left him off so you guys could see that he meshes well with his parts. And that's just doing a straight subtraction, no keys. So now, that's how I do the keys. Now let's go into some hollowing. All right, some of these questions quick. Oh, yes, the ancient ZBrush, the ancient Egyptians ZBrushes. So Makan is asking, is there a way to move the default spacebar hotkey? There is not. You are always going to have this. I would like to be able to change this to just the S key, but alas, this is what you get. Size of the model is set to 8 inches tall. So it's 8 inches from his top of his thing here to his feet is what the current size is. So John Yu is asking, would it be easy to make the weapons separate from the hands? Yeah, there's no real difference here. It's just personal preference. If you wanted to make this separated, you know, I have some clear intersection points here. I could have done a hole that would go through this part, and then put a hole in the weapon and I could even run like a piece of aluminum wire or something through it, and that would end up making this rod that would go into there. It's really just, it's no more steps, it's just preference. So yeah, you can definitely separate the weapon if you wanted. You just gotta find, I personally find that just having an area that would be a believable transition is what you're going for. So yeah, you could separate however you wanted. There's no restrictions on what you're doing. This was just a clean separation through here. And I know I didn't want a massive amount of pieces that I had to connect together, so I just kept the hands with the gun. And then this still allows me, if I printed this out and wanted to paint it, I could still go through and paint this stuff all over the place. You're welcome, Doug. Use it. Yes, so we're gonna do hollowing right now. Beveling edges, there's a ton of ways, panel loops, other stuff. One thing I'd say, try to do if you have polygroups, go to crease, hold down control, and use this bevel width. So that was Skull Senpai asking about how you make beveled armor. You can check, you can do analysis on the model inside here. So okay, well here, let's do this. So hollowing first so you guys can see this. And then I'll show you there's an analyze subtool here you can use. So we'll just tell you if it's watertight. And you could also use if you were here earlier, I was running a cube through the mesh to kind of view it in a slicing format. You can definitely do that. You can also check your mesh. If there's anything that's gonna analyze it like 100% other than, you know, telling if it's watertight, which is your primary concern for 3D printing. And then most of the stuff for the other checking, any of the slicers will do, which ZBrush is not a slicer. So you would have to run any of your models through an application that would bridge with the printer. Another question, is there any good printers with poly painting? Mickey Maku, oh man. I can't remember how to pronounce it, but there's an excellent 3D printer. It's what Funko uses for all their Funko Pops for when they're prototyping. So Funko uses ZBrush and this printer. So they'll sculpt everything in here to make their pops, and then they send them out with color to this printer. The color prints it, and then they have their prototype. And that's it. It's like a single step stop. And it's Miyamaki. Daisuke may be in here. He may be a help. Yeah, there we go. Miyamaki. Yeah, and the color is awesome on it. It looks really cool. So definitely that's the top one for color right now. All right, so for hollowing, let's take an example here of the boots. So what I want to do is, if I'm printing with SLA, this is solid right now for FDM, so it has no hollowing. Now I'm doing this on a lightweight version of a mesh here because the hollowing process does take some time. The one I'm going to show you here with Dynamesh. It does mathematically, which is why I end up using it the most. You can definitely just take any object and set it as subtractive and use it as a subtractive form. But if you want to do it automated on it, then you can use the Dynamesh process here. So with the boots, I'm just going to split these off so they're their own separate one, just so it's a little bit faster. So I'm going to auto group, and this now gives me 2 boots. And then I'm gonna isolate one of these and then just split hidden. So now I have boot 1 and boot 2. And with boot 1, you have some options for your dynameshing, for your hollowing. The easiest one is if I go to Z plugin tab, and this is the Dynamesh master plugin I just downloaded, right? This is the one I got off the Resource Center. There is a create shell button right here. So over here I can set my thickness. We'll set it to say 4, and it's gonna be in millimeters based on the size of your object. So if you got your model sized already, come over here, type in 4, it's gonna give you a millimeter thickness of 4. Then I can just simply come over here and click create shell. And this is gonna tell me I need Dynamesh active. So before you use this, you need to Dynamesh your part. Now, one thing nice about the live boolean is you don't have to use Dynamesh, but if you're gonna do hollowing and you're gonna use this process, you're gonna need to use Dynamesh. Now, if you only wanna use hollowing for the process with Dynamesh, you can actually just duplicate your tool. This is gonna keep your boolean version of it, and then we'll make a duplicate version of this that will actually Dynamesh. And we'll come through here and do this. And then we can cut out the inside and use it with our other version of it, so we don't have to Dynamesh our entire model. We just Dynamesh the inside. So a little trick here too with that. For resolution on this, it's just gonna be dependent on your size. The size in ZBrush for your optimal Dynamesh resolution is gonna be based on the internal size of your model. So a size of 1 at the resolution of 4096 is gonna be the max Dynamesh resolution you're gonna be able to get on a subtool. So 2048 for this mesh looks pretty decent. We just want to hit a number and a resolution that roughly equals the same amount of polygon resolution. And then if you just undo and redo, just make sure I'm not losing any of those details on this model here. Now, after you have Dynamesh active, go back to Z plugin, make sure we got my thickness. If you're doing a slider again, make sure you type it in and hit enter afterwards, and then click create shell. And this is going to process this, and hopefully I don't go robotic. And this one should be pretty quick. I use both. I mouse and tablet. I go back and forth. I'm one of those people that switch. Mimaki. There we go. Thanks, Daisuke. All right, so this Dynamesh process, if you're using the plugin here, there's also a way to do it manually, which involves adding an object that would be subtractive and then doing the Dynamesh. But the easiest way is just download this plugin and then do the create shell, set your thickness, and be done with it. It's gonna be the best way to do it. Now, this process will take some time if you have a mesh that's really, really solid and really high polygon. So like this one here, this body part that I had originally, this part here, if I were to do this with the hollowing process right now, you guys would all be asleep. So it does take a little while on high density meshes. So this was 3 million and this one takes a little while to hollow. So that's why I just did this boot here for my hollowing example here. Now to test the hollowing, I can insert in that cube again, and we'll zoom out here, scale that cube down, and then activate live boolean, put it subtractive, turn off solo, and now you can see as I go through the boot, you'll see that 4 millimeters wasn't very thick. So I should probably do a little less. I've got let's go over to my all hollowed version. And let's go, and we'll actually do the body for this one. And insert in a cube again. Not a cube, that's totally not a cube. Set it to subtractive, turn on my main body, make sure live boolean's on, and scroll through. Make it a little bit bigger. And you can see it's gone through and it's generated thickness all the way through the mesh. So this is done by mathematical calculations. This is why it's looking a little bit of this kind of stair-steppy on the inside. So it's looking at all the faces on your mesh and calculating inward and then generating geometry inside of it. But this will give you that thickness all the way through. Now this thickness will vary in some parts, so it's not gonna be the 100% 4 millimeters everywhere, but it should be pretty close, especially this kind of printing through here. Now after I have this hollowed, this mesh is still solid. So the hollow body inside the model is basically just a cavity that is rendering backwards. So that's pretty much all hollowing is, right? So if you have an object and you have a smaller version of it on the inside and you have the normals flipped, the mesh is hollow. And that's the whole process here. So I can go through and I can come through, so I can go through and I can do an auto groups now. And this is going to now separate the polygroups, and it's going to set those inner cavities and the outer cavities. And if I hold Control and Shift, and I can select the outer, and then if I click it again, it's going to show me just the innard. And now at this stage, this mesh is hollowed, right? So if I was putting on a Form 2, I'd want to go through and make some vent holes in here so that the stuff can leak out. Also, I want to check on for areas for suction, because basically if it gets sucked on the thing, you could end up getting exploded print, or the could bubbles all over the place. So oftentimes for vent holes, you'd use the key portions of your mesh. But what I want to do too is also show you that even after you've done this hollowing process, you can still use this to your advantage. So I can split this off, and now I have basically my original model that's not hollowed, and then I just have the hollowed or the internal part, right? And so this is what I was talking about earlier. If you don't want to dynamesh your model, you can just make a duplicate of it, dynamesh it, generate your hollowed part. And now with this hollowed part, if I flip it, I now have the inner volume, and now I can just use this as a subtractive part with the boolean. So I've just taken the dynameshed hollowed part, I've then flipped the faces, or detached it from the original one, flipped the faces, and now I have just the hollowed inside part. And now at this stage, I can do whatever the heck I want with this. I can smooth this out, I can remesh it, I can change the geometry of it. It's just giving me that internal section. And I can just set it as another subtool. So there's a lot of functionality you can do after you've made the hollow. Don't think it's just part of your model. You can definitely play with it, cut it up, and do different things with it. And I think Daisuke is asking some different things here as well with it. But yeah, but there's a lot of different things. So, but I usually end up using that, and then I'll split it off. And then now this lives as its own subtool. So if I need to change it, I don't have to reprocess the entire mesh. I just change this, and this is generating that inner cavity. And then when you process with the boolean, it's going to give you a result. Yes, I use the mouse for ZModeler. For adjusting sliders, I also use the mouse. For explaining, sometimes pens. It's all over the place. So Dougie's asking, when using the quick scaler, which was the plugin here, do I usually just end up using a percentage value to decrease my key sizes, or do I use a millimeter inch value? Usually percentage is what I use. And relatively, I err on the size of that offset of that key being larger than normal, because as I mentioned with this, to solidify him and put them all together, I just use Gorilla Glue, and Gorilla Glue will fill that gap. It's a lot easier to fill a gap than it is to remove material to make the gap work. So if your keys are like really tight, it's a pain to go in and sand those off and sand the stuff to get it to fit. So just, I usually err on the area of the mesh, or the keys being, the offset between them being a little bit larger, because then I can fill them. And you can fill them with clay, you can fill them with wood filler, you can fill them with all sorts of stuff. So I usually err on larger offset than smaller ones, because it's really a pain to sand stuff down. I see Gobi's on. Hello, Justin. So got a question here on what's my most recommended 3D printer. So I do like the Formlabs machines a lot. Right now it's very hard to get IPA, or the alcohol, in order to clean them off. And also my resin tank, I need a new resin tank, so that's why I printed this one out on FDM. For FDM, I've used Ultimakers, I've used all sorts of stuff. There's a whole wide range. Basically precision is what you want, because you can get a really cheap FDM printer for not like $400, $250, and it's going to give you a good result. So it's basically just a hot glue gun that's extruding, and it just has stepper motors. There's really not much technical stuff in there. It's feeding it pretty much G-code, and then it's moving the access points and growing your print. So there's a lot of really inexpensive printers that are going to give you a nice result out of it. And then this has all been done on my MakerBot Replicator 2, which I've had forever. And so it's been a workhorse. It's not the top of the line, it's not the best thing that's out there, but in terms of how it prints and what it gives me quality wise and the speed, and it's cheap to run. Like it cost me, like a spool of filament is 20 bucks. And so it's a very cheap printer to run and use. And so I'll use that for a lot of prototyping. And I tried it, like basically just want to know your scales of it. So like for anything on an FDM, printing large is going to be your best thing, because you're going to be able to get those details you want. If you're doing rings, jewelry, anything small, you're going to want an SLA machine, because you're going to want to get those details and your prints are going to be smaller. So it's just back and forth. So for exporting this model, so let's say after I have him all set up, I'll show you the final one here. This is the version that has been done. So I went through and made all the keys. This is non-hollowed, so this is the one that I sent to my MakerBot. And then to export this out, if you've used Scale Master, and so you have your model set to scale from here, all I do to export these parts out is come up here to Tool and click Export, and then export this out. And usually I just save them straight as an OBJ, and then I'll take those and just import them into my slicer, and that's it. You can also export out STLs to here. The key thing to note is if you export out of this export button here, it's going to remember what you have set for Scale Master. If you use the 3D Print Hub, it's going to use these values here. So just remember that. So if you have your model set up with Scale Master, just export out over here. And let's see this. The schedule for live sessions, I see Daisuke's already got that. For the little guy, the tiny little guy that's on the thing, I did not. He was just 100%. There was no offset on him at all. I knew he was gonna float. Like, he's not a pure thing. So there is like, I mean, it might be a millimeter of gap, maybe a half a millimeter in there. It's not much though. And so he's also kind of just gravity sitting too. So he has some wiggle, but it's actually pretty good. And then I wasn't going for 100% sealed print either. So he does have, like, his boot's off a little bit and he has a slight gap on the one side, but overall he's not going anywhere. Yeah, I mean, you can move him around and jiggle him, and he's gonna ride the Proko collaboration model there. The Pixelator is what I'm calling him. Yeah, I was thinking about doing got a comment on, instead of IPA, using mean green or simple green. Yeah, I was thinking about it. I just haven't got around to it yet. All right. Well, I think that's the end of today's stream, and so we'll go big one more time here, so you guys can see the final Proko model here. There you go. That's what he ended up looking like. And so hopefully some of those things helped there. It was we went off on a little bit, maybe too many tangents today. But that's the MakerBot version of this. So that was it for him. And he took about 30 hours to print him on FDM. So the MakerBot's not the fastest machine in the world, but it definitely still holds up and gets the job done. And this, I often do this too if I'm modeling things, and even for like doing a print, like say, even before I would take this model and set it up for a form to SLA print, where I'd go through and make sure it all fits and get the details, all the keys, all the hollowing, I'll run test prints on the FDM. And I'll often run them even smaller too, which doesn't take that long. Like, I'll run them tiny. So I'll just merge everything together, apply the union so it goes solid through the entire thing, and then just send it to print. And then that gives you at least a quick result of the model in its true life. And so then as you rotate around it, you can see if there's anything broken, wrong, and then you can make the changes quicker, and it's not gonna cost you the reprint on, say, like a Form 2. So all sorts of things like that. For one more question, but I'm not gonna be able to go through it in time. How would you figure drainage halls for resin printer? So for the resin stuff, it's kind of hit or miss. It just depends on what you're kind of doing. First of all, I knew I was gonna print him like this, vertically, right? And so for the resin holes, basically for me, it comes down to where can I put them where they won't be obvious. So on keys are usually my go-to. Like, I always put holes on the keys here. Like, I'll have holes in all these, sometimes on the body itself too. And then other areas, if you need to do them where they may be visible, I'd do them on flat surfaces. So something like this, I'd put a resin hole in. Anywhere that has a flat surface is also easy to patch and fill. I wouldn't want to do it in an area there's a lot of detail. Like, I wouldn't put it, anywhere that's a primary target to, like his helmet. Oh, I'm not really showing you guys anything. I'm just talking and looking at myself. So I'd put them on here in these areas. This areas would be another one. Flat surfaces like this, I can put a hole. The main thing is that the hardest part to find in terms of where to put holes is the suction. because there's no way to really calculate where that suction is going to be. So until you export this model out and see it in the slicer in preform, then it's going to tell you, hey, this is going to give you a suction problem. And then after you have that, I go back in here and I'll fix that problem. And so what I end up doing is I'll go through and I'll just have like little pins that I'll put all over, and I'll just keep them as a separate subtool so I can move them around, right? So instead of fully committing to those holes for where the suction could be, you know, happening, I'll just temporarily put them in. I'll generate the model quick. It doesn't have to be the greatest version of it. I just run the boolean quickly, decimate it if I have to, send it to preform, have it look at it, have it calculate it. If that hole needs to be moved, then I go back into ZBrush, just move that part, and then just re-boolean again, and then just go back. And so there's a little back and forth in terms of that stuff, especially for suction, because that stuff for me, I can't calculate in my head, really. I just kind of guess at it and then hope for the best. But then preform yells at me and goes, hey, there's gonna be suction here. And then I gotta go back and fix it. And for that stuff too, don't ignore it, because it will give you a line on your print. Like you may think, it's not gonna be bad. But the problem is that it creates a suction, and then when it goes to wipe, it shifts the print. And so if it shifts the print, your next layer is gonna be offset a little bit on it because the suction was too strong to break it from the thing. And so definitely, if you ever get a suction error, fix it. If not, you're gonna have a print and it's gonna have a clear line where that suction problem happened, so. All right, well, I think that is it. Thank you all for coming out. I think we're still scheduled on doing the kind of developer streams for the next month as well. Once again, if you are looking to try out ZBrush, there is a 2020 trial which you can download from Pixologic.com. This is a 30-day full-featured trial, so you can do the exact same things I was doing today. You can also download plugins, and so those 2 plugins I was downloading are on our resource center here. So I grabbed the Dynamesh Master plugin for the hollowing process, and then I grabbed the Quick Scaler plugin up here for the scaling. Another thing that's nice with the Quick Scaler plugin is that recently it will now work with the transpose line too, so you can actually set your keys and you put the transpose line behind it, and you can actually rescale based on that transpose line, which is a cool thing too, especially if you have keys that may not be fully embedded into your model and you just need to resize them. You can set the transpose line in the back of them and it's going to size from there rather than sizing like this. So cool little thing there with that. I think that is it. Once again, if you haven't seen the ZBrush Masters, Marco Plouffe went yesterday. You can go to the calendar page and find that. Also today after me, we have Ashley, A Cubed, will be streaming on our channel here too, so definitely check out her streams. She's always doing some amazing monsters, so definitely check her out as well. And that is it. So this will be the final chapter in the Proko collaborations. This was the bonus part 4 one there. If you want to get more information on that, you can definitely go and check out Proko on YouTube, and then just do this. I have a link here somewhere. Let me get that. Let's paste that in there. It's also on the calendar. And you can go and check this out. In here, there will be a link to all these. We'll see if my Restream lets me type this out. And you come in and watch the streams in this series. And then this was the 4th bonus one, which was not part of the collaboration, but I wanted to 3D print the model out, so you guys got some little information out of it. That is it. Thank you all for showing up. And until next time, stay safe and happy ZBrushing. Thank you all. Thank you, Daisuke, for answering questions in the chat. I appreciate it. Bye-bye.